So by the end of this video, we're going to make a separate delay helper, which will allow us to easily delay an action and then call a function after it. And we'll end up creating a cube that will explode on contact after a certain amount of time. In this video, I want to talk about an easy way that we can delay a task that isn't the default invoke that comes with Unity. So maybe you've seen this before. Maybe you've tried to wait for a second or two inside of a prototype you're building, and you may come across this function called Invoke. But you'll also notice that it takes in a string reference to a function, and that's not so great. What if we misspell this? Then it's not going to work, but it's not going to give us an error, and it's really difficult to troubleshoot. So then you think, okay, well, maybe I have to use a coroutine, which is a way in which we can wait for some amount of time by returning back to the main thread and then returning where we left off, and then coming back here and then waiting until 0.1 seconds has passed. And the problem with this is you can see it's a lot of typing here. If I just want to wait for some amount of time, I want to be able to do something like this where I can just say, well, call this function and then give it a function, not a string, after some amount of time. And then it'll come down here and call the function. So we're going to set that up, and we're going to make our own little custom static class that we can delay a function call for some amount of time, and we can reuse it inside of our scripts. So I have a little setup here. Level controller, all this is, it's a level controller object with a level controller script. You open up the level controller script. Then inside of here, inside of update, I'm testing if I press the space bar, then I'm going to print to the console, start delay, and you'll see this is the way we don't want to do it, is invoke, do something, and it'll look inside of my script for a function called do something, and then call it after this amount of time. Now the problem is, what if I had called this zoom thing, right? Like just a little typo here. If we play and we press spacebar, right? It's trying to invoke something, but it's not finding that because it doesn't exist, right? We don't have this other spelling version of this. So this is kind of not great to troubleshoot. So just be aware of that. We're going to create our own just to show you that you can, but we want it to function as the same thing. So really what we want to do is we want to wait for some amount of time and then call a function that's inside of our script. So let's make a new script. Inside of scripts, I made a folder called utilities. I have other tutorials like an audio helper one that will let you easily call audio from other places. We're gonna make a new C# script, and we'll call this delay. We'll just call this delay helper. Open this up, and now we are going to add some functionality here. So the first thing is everything that goes inside of the delay helper class, I want them to be static function calls because I want to be able to say delay helper dot something no matter where I am. But keep in mind what that means is that we cannot have any instances of anything, which means we don't even need a mono behavior. And this will not exist inside of our scene. It'll just be code inside of our project assets, which is pretty cool. We can call it from anywhere, which is what we want. We're in play mode. Let's get out of there. So this is optional. I'm just enforcing that all of the functions inside of here will be static. So we're still going to use a coroutine, but we're going to put all of our reusable code in here so that we don't have to start and stop it inside of our scripts where we want to call them. So I'm going to go inside of my delay helper. First thing we need to do is we need to make a public static. And because I can't really run a coroutine on a static class, we're actually going to run the coroutine on our level controller script or wherever you call this from, but we're just going to hide it. So we're going to filter this all through an expression, or we're going to filter this all through a function call. We still need to reroute this through our static function. So we're going to call this delay action. And then we need to think about what we need. So when we start a coroutine, we need somewhere to call it, but then we also need to run it through an enumerator. So I'm also going to make that down here. enumerator, and we'll call this delay action. And I'm just going to use, for naming purposes, I'm going to call it the same thing, but add routine, just so I know that this is This is where I'm actually cycling through. Okay, delay action. Now, I need to actually pass a mono behavior into here because this is a static class and I can't really have any instances of anything inside of this class, or else I can't run it from anywhere. I need to get a reference to something. So just inside of my parameters, I'm going to pass in a mono behavior script that we can use just to run this thing on. I need a function that I want to run, and I'm just going to use the action keyword here. But you'll notice that it's not auto-completing. That's because if you want to use an action as a part of C#, you need to add the using system at the top. And you'll see that it recognizes it now. So action, and we'll just call this action, it's the function that we want to run. And then how long do we want to delay? So we'll call this delay duration. So now that we have our parameters, we need to pull it in. So because we are rerouting this through this function right here, this is going to look a little bit weird, but we need to start our coroutine, but we need to start the coroutine on the script that we pass in. So we're really running it on our level controller in this case, but we need to assign it to it. So to do that, return our mono behavior that we're passing in, dot, and then we start the coroutine on it. So mono behavior dot start coroutine, and now this is the coroutine that we want to start. So I'm just going to pass it in like that. And now you'll notice we still need to run our action and our delay duration inside of our enumerator right here. So I'm just going to pass this in, just kind of routing it through really. And mainly this is just to save time and typing. There's a concept called dry in programming. It's DRY, don't repeat yourself. And we're going to do this all in here. If we ever need just a really simple coroutine and a script that will run the coroutine, wait, and then do a thing, then we can just do it in one line here instead of retyping it every single time. Okay, so down here with our coroutine, we need to pass in our parameters, right? Our delay action routine. So we need our action and our delay duration. So again, we're going to call this from anywhere. We are going to pass in our action, pass in our delay, and then we're just going to route that into right here. The other thing is just to keep in mind, we made this private because we don't want anything to run this. This is just for the delay helper, but anything will be able to call the delay action exposed function. All right, so all we need to do now, easily enough, is yield. So we want to wait. So yield return new, wait for seconds. We want to wait for whatever duration we passed in. And then after that, we want to run the function. Just whatever function we originally pass into here, we want to run that after we pass the duration. So this may be a little bit confusing. It's a little bit weird because we had to route it into a static function, but we're really just running a coroutine on our level controller, but we're doing it underneath the hood. So what's nice about this is that to run a coroutine, instead of doing start coroutine and if I bring up my API again, all the stuff here that you see in coroutine where you have to start one, then declare an IEnumerator, and then do all this other stuff here. If we just want to delay an action and then run a function, do this all in one line. So we'll just do delay helper, which remember is our static function, or this is our static class, but then we can run our static function inside of here. So delay helper dot delay action. So now it just needs three things. It needs the mono behavior script that we want to run it on. In most cases, it'll be wherever you call this from, but if you wanted to run it from a different game object, you could pass that in too, but you do need access to a mono behavior script. So because this is a mono behavior script, I can just type this, so it's this script. And then what function do we want to run? Well, do something, we'll just copy paste that. And then lastly, give it a duration. So I'm just putting a 1.5 there. So in one line, we are running a coroutine and we are waiting some amount of time, and then we are running a function. So what should happen is when I press spacebar, it will wait for 1.5 seconds, and then it'll run this function, which we'll see something happened here. So if I hit play, spacebar, I'll just try that again. And you'll see it'll wait 1.5 seconds, and then we'll see this. So this could be any other code you want, right? It could be anything. So now I want to show you a more practical example here where you can use this other places. So let's say we have a cube, and I have a cube here. I want to be able to drop this cube, and when it touches the ground, I want it to wait and then explode. So in order to do that, I do want to tell you that beforehand, I did build this explosion particle, which is just a really simple, you can make this. I have another tutorial for a collection particle burst, which is very similar to this. You can just make any outwards explosion. So I have this already. I also have an explode sound. Right, so as long as you have those two things, you should be able to do this pretty quickly. So I'm going to make this cube, I'm going to call this explode cube. And just to show you how we can use our delay function, I'm going to right click, I'm going to make a new script and call this delayed explode on contact. And then we'll put in the script information there. But first is I want to make this drop. So I'm going to add a rigid body. Make sure it's using gravity. So we should have this. Right? And then when it hits the ground, we want it to do something and then explode. So the first thing I'm going to do is I'm going to open up my delayed explode on contact script right here. I'm going to make sure that I did attach this to the cube. So I'm going to just say this cube now has the behavior of delayed explode on contact. So now that I have that, first we want a sound effect to play. Let's explode sound. Then we want a particle system to play. Explode particle prefab. Because we're going to instantiate this, we actually want this to be a prefab. Make your explosion particle, this is what it looks like inside of your scene, then just make it a prefab because we don't want this to exist already. So once you have those two things, first thing you want to do, because we want some sort of visual, we're going to access the material to change it different colors. So when it's about to explode, we want to turn it red. So the first thing is I'm going to cache the material up here like this, and I can null it out, just good practice. Okay, on start, I need to find a way to get the material attached to this game object. So easily enough, I could just do get component, get the mesh renderer, which, right, our mesh renderer right there. And I'm going to drill down inside of that component and get the mesh renderer's material, which is the material associated with this mesh renderer right here. And this could be anything. I'm just using this as an example. Now, on collision, enter. And in order for this to work, we need to make sure that our cube actually has a collider right here, not a trigger volume, a collider. Whenever we collide with something, we want to start building up the explosion. So to do that, we're going to say, change the material's color to red. Doesn't really matter what you do here. It's all just visual. Finally, the thing that we're trying to show off, we want to delay. So we want to change the color and look like it's about to explode, delay for some amount of time, and then activate the explosion. So we'll say delay helper, delay action, this explode 1.5f. Now remember, it's now looking for a function called explode. So we need to make that down here. So now it will run this function after 1.5 seconds. And if we wanted to give this to the designer to control, we could put that up and expose it, but just trying to keep the example very simple. So now we can put all our fancy visuals in here. So, and I'll also add a note to do we're going to spawn particles and audio at runtime, but we may want to put this in an object pooling system if we're starting to optimize later on. So I'll say to do integrate object pooling, then do our audio, then do our fireworks, other code, anything else, apply damage, etc. And then we want to destroy our game object. So we're going to spawn our audio and our particle system in the scene because we want to destroy this object and we don't want them tied to this one we're going to destroy. So we're just going to spawn them. Again, object pooling is best for this, but we're going to use the audio helper that we had already written in a previous tutorial, and I'm going to show you the code for that real quick. Audio helper. And we're going to do play clip 3D, and it looks like this. So if you want to just copy that, you can. Make sure that you have the static class and static, and you're not inheriting from mono behavior right here, just like this. So our audio is going to look like this, audio helper dot play clip 3D. We want to give it a audio clip to play, which is our audio clip up top here, our sound. Want to give it a volume, so just one. Want to give it a position. Well, if I say transform position, that's going to play from the position of whatever the script is attached to, which is the cube. And then give it a radius. I think we'll give it a minimum, I don't know, this is pretty loud, so I'll just say 3, give it a maximum of 50. And you could adjust this. This is the minimum distance where you can hear it and the maximum distance you can hear it. So that should spawn a new 3D audio clip in our scene. Then we want to create our explosion. So we're just going to instantiate that. And when we instantiate it, I'm going to hold on to it. Call this explosion particle is equal to instantiate a new game object from the explode particle prefab. And then we'll have to drag and drop that in a second. Create this at some position, which will be the position of this cube right here. Just it says inherit the rotation. Don't do anything with it, just use the prefab. And then finally, want to tell the particle system to play. So this is why we're holding on to it right here. Just want to say this dot play. Okay. All right. And then we could apply damage and do other things if we want. But if we have this and we save it, we come over here, let it recompile, go to our explode cube, make sure that we fill in our references here. So what explode sound do we want? Well, we want whatever sound you want. Like you can find a wave file or whatever and import it, then drag it in here. What particle prefab do we want? The one that we already set up down here, saved off as a prefab. And let's review this real quick before we hit the play button. We are specifying a sound inside of our resources to play. We are specifying a particle prefab that we want to play. We're going to change the color of the material. This is just a visual thing. You know, this is optional just to show you that we're starting something, we're delaying, and then we are exploding. So we're getting that on awake. Whenever we collide with something, we are changing the material's color to some other color. Then we're saying delay helper, wait for 1.5 seconds, and then explode. And then to explode after 1.5 seconds, we'll spawn a new 3D audio. We will explode the particle, right? We'll create a explosion particle and then play it. And then we will destroy the cube object. Let's see what that looks like. Cool. So let's play that one more time, and I want to hit pause here. And you'll see that we created our 3D audio, we created our explosion particle, our cube no longer exists, and you could do other things like detect a radius of things around to apply an explosion. But really what we were trying to prove is that we can use our delay helper really, really easily. Anytime we want to just create a simple coroutine that waits and then calls a thing, it saves us a lot of code, offsets this into a different script that can just exist inside of our project files, and we don't really have to do anything with it. Just be aware that the downside of this method is that we don't have any control over the coroutine once it's started. So for example, if we wanted to stop the explosion once it started, we don't really have a good way of doing that with this implementation. Just know that that's the downside. It's kind of a fire and forget, but it is really handy if you just want to do a simple wait on a thing and then run a function after that amount of time. The other downside is that technically we can call this multiple times in a row, and it will call multiple coroutines that are doing the same action, and it'll trigger them appropriately, right? Like each coroutine will be running their own cycle, and they're not necessarily talking to each other. So if you spam a button that starts a few things, it may cause you trouble in your logic if you're not accounting for that. So this is meant to be just a really simple delay action and help save you some code from a really simple coroutine call. So it's kind of handy. Just add it to your toolkit and use it when appropriate.